this is a tough act to follow. Really good presentation so far. So this sort of is a good segue from Elias' talk into similar topic, but things you can do by yourself to mitigate the risk from APIs. So the talk is called API SOS, a tactical guide to detection and response. All right. Okay. I'm Anjum. I lead the security research team at Traceable.ai. Traceable provides catalog, runtime protection, and application testing for APIs. Prior to Traceable, I was at Cloudflare doing detection and response. Was there for over 5 years. And then I've held multiple threat intelligence roles at Cisco and Endgame and so forth. So I've spent a lot of time doing threat detection and incident response in my career. And in the last few years, I've worked on API security. And I believe that organizations are not including their APIs in their threat detection and incident response program. So today, we will look at why they should. And we'll talk about how you could do this yourself, how you could build out strategies and process to do logging and monitoring of your API traffic. So we'll start off with some snippets from the marketing research. Eli had shared some similar numbers. The two key patterns here. API adoption is on the rise. RESTful APIs are still at 85%, but GraphQL and gRPC are quickly ramping up. And B, API-based breaches are increasing year over year. The number over here, 681% from Nordic API itself. I mean, if you believe these numbers, then the breaches and API adoption are not even linearly correlated. Why is that? Firstly, if you think about traditional abstract vulnerabilities like SQLi and XSS, it follows a particular pattern. A lot of the traditional WAF providers have written signatures for those particular vulnerabilities, and they can catch them. But API attacks look very different. They look like regular traffic unless you know what sort of context it is running in, what sort of parameters it's supposed to have versus what the parameters it's sending. So our traditional security measures aren't helping us here. For my second point here, I'll tell you a brief story. So back in 2022, LastPass announced that they had a security breach right around Christmas every time. A threat actor had access to their vaults, and those vaults, depending on how old those vaults were not very hard to crack. My organization had API keys in those vaults. So we wanted to rotate those API keys, and we went around looking for where we had our API keys. And it was a nightmare. It took us 3 to 4 months. API keys are everywhere in our organization. It's on our infrastructure, in prod, dev environments. It's in a CI/CD pipeline. It's in Kubernetes variables. And God forbid, it's in your code. It's in your in-memory databases. And to make matters worse, APIs often don't have any expiry. APIs don't often give you tools to geofence it to a particular IP or IP range. And oftentimes, APIs have just excessive permissions. I don't want to shame any particular SaaS provider, but there is a SaaS provider that I bet like 90% of us have used that lets a limited user create an API key that has complete access to the whole platform. And even if you remove that user, the API key lives on. So you're dealing with a very weak authentication mechanism that's used prevalently. It's spread everywhere in your organization. The third point here is excessive data exposure. APIs by design are meant to work with multiple clients. Think about your client-side front-end JavaScript. Think about mobile applications. And so a mistake that often organizations make is they build APIs in a manner that it sort of returns a superset of data that is required by each client and let the clients do the filtering. Gone are the days where we were doing server-side rendering, right? So by design, an attacker could just spin up their own client and then access all the traffic, all the API payloads from there. We can talk about dormant and shadow APIs. I mean, if you really want to look for companies' skeletons, API skeletons, just decompile their historical mobile applications. The latest mobile application will have a V2, and then go down a few versions, you'll find a V1 that's still hanging around. No one is maintaining it. No one is doing bug fixes. And that's how attackers get in. With this slide, we covered a lot. But what I'm trying to get here is that APIs have its own unique attack surface. And our traditional security controls aren't really helping us here. But if you're still not convinced, I'm told that memes really help. So what should we do? So we should log our API traffic. So when it comes to logging API traffic, we have a few options. We can log it inline, or we can do it out of band. We could log just a URL and a few headers, or we could try to log the request bodies and response bodies, the whole shebang. We could aggregate the logs. We could filter and sample it, or we can store all the entries. It could be in a raw format, the way HTTP form protocol is, or you could actually do something more here. You could parse out the query parameters, you can parse out the path parameters, and store it in a structured format. So what you do here depends a lot on your architecture and budget, but generally the option on the right is the preferred option. How you get your API traffic? This falls into three major categories, right? You could do traffic mirroring, think sidecar proxy. You could do tap into your API gateways and load balancers. So for example, you could have a Cloudflare Edge worker that's intercepting every request and then logging it along the way. Or if none of these options work for you, you can actually log it from the host. You can have an eBPF sensor, or you could log using application journal logs and so on. Very typical ways of doing it, but depends very much on your organization. And if you go down this path, I would recommend these three open source projects can really help you along the journey. Here's one extra thing you could do. Again, I've done this a lot, detection response pipelines. Being able to enrich your data before you store it really saves a lot of trouble later on when you're using it for threat detection and incident response. So I would recommend to, if you can, enrich your data. Parse out the JOT. We talked about verifiable identities. JOT have these whole payloads with claims, with scopes, with expiry. Parse it out along with logs and store it along with it. Enrich your IPs. Figure out where who is using your IP addresses. What kind of IP addresses they are. Are they data center? Do they belong to some anonymizing service like a VPN or a residential proxy? And lastly, if you happen to have your OpenAPI spec, the security scheme is really valuable to know what to expect. What sort of authentication mechanisms are there? What sort of scopes are required for each APIs? Have it along with your data to join to figure out which APIs should expect what sort of traffic. So these days, we work with a lot of organizations figuring out their risks and what they're worried about. And these risks fall into these 5 categories. And we'll walk through each of them, ask what sort of questions we should ask from this data that we have just collected. Authorization bugs, out of the OWASP API top 10, 3 of those vulnerabilities are authorization bugs. Broken object level authorization, broken function level authorization, broken object properties level authorization bugs. These happen when a threat actor accesses a property, a username, a user profile, an object like your orders, or a function like deleting a user, and they're not authorized to do that. So you can ask these questions from this data. Is there a single user session that accesses a lot of user IDs? There was a recent breach that happened where a logged in user could just access anybody's personal profile, a lot of details about them by directly hitting the IPs, by directly hitting the APIs. You could look for a single user that's enumerating a lot of objects that may not belong to it. So this is how it may look like in a SQL format. If you have already parsed out your query parameters, easy. But if you haven't, you could parse it. Let's assume you have an API that has user/user ID/object/object ID. You could parse out a user ID and object ID, and then group them and count and group the distinct objects they have accessed. Think about it. When was the last time you accessed last 20 of your Amazon orders, right? So there is a easy way to sort of have a normal threshold of how many objects do a user access, and then alert if someone is crossing the threshold. The second flavor of authorization bugs come in when a low privileged user accesses a high privileged API. Now, how do you know which APIs your privileged APIs? You may have an admin substring in your APIs. That's great. Or if you have your OpenAPI spec handy, you could use a security scheme and match the scopes for each API with the session scopes that were assigned during authentication. Authentication bugs, I mean, I could do this whole session by itself. So my team does vulnerability research and disclosure, and there's a particular pattern that we see all the time. You'll find a website that has a proper single sign-on website for an unauthenticated user. The user logs in, think of all good OAuth practices, user logs in, but all that the front-end JavaScript does, it sets the user email or user name or something predictable as a variable, and then that is used for all subsequent APIs. This pattern repeats over and over again, and this is basically one example of authentication bypass. So you could look for that, right? Are there any APIs that are being authenticated APIs that are being called in your traffic without an auth header? Is a session being used beyond their expiry? Remember, the JOT that we collected earlier has an expiry, and if somebody using the JOT post expiry, is there a particular login API that returns a different status code based on whether the user is invalid and a password is invalid? If an API has that, somebody could actually just scrape your website and just enumerate all the users on your platform. Next up is account takeover. Again, comes in multiple flavors. We'll talk about two. One thing that we see often is, especially in financial sector, is someone would set up a fake domain that looks like a bank, evilbank.com. They will have the user log in, even sometimes with multi-factor, and then collect that credential and then redirect you to the actual bank and hope that the user doesn't notice that. The way it shows up in your API logs is pay attention to the refer domain. We see this oftentimes that the refer domain to the real domain contains the domain name of the phishing domain. Or traditional brute force attempts, which you can easily look for by just calculating the number of successful login attempts and a failed login attempts, and if that ratio looks weird, there's someone trying to brute force. Fraud and business logic abuse, again, comes in many different flavors, but these are the three common use cases that we see in different sectors. Content scraping is seen very frequently in e-commerce website, where someone may try to scrape your content for specs or for pricing information. The way it looks in your data would be someone, if the website has multiple orders in a pagination form, you may see someone accessing all the orders in that same order. Or if you have an API, let's say a GraphQL API that we're seeing quite often these days, where you could pass on a product category and product ID, and then you see these GraphQL APIs where someone is just single session and multiple product categories are being accessed. SMS pumping is interesting. We're seeing this a lot in Asia Pac, where a threat actor can actually make money by sending a text to a phone number. So the way these attacks are done is someone could try to change their phone number multiple times to generate a verification code, or they could try to log in multiple times and just keep generating OTPs. And over hundreds and thousands of on a non-rate limiting API, they can really rake up some budget here, bill here. Last but not the least, card testing. Here's the way the card testing fraud is done is someone has access to stolen credit cards, and they would like to know what sort of credit limit is there on that credit card before they can resell it. So they would come to an e-commerce platform, try to buy something, but will never finish the order. So you see multiple attempts to change payment, or you see attempts to change the cart, but a payment is never complete. And again, easy thing to do once you have data in a database to search for such attempts. I'm a big fan of honey tokens. Honey tokens are these, API keys, fake users and products that you can sort of deploy in your network with the sole purpose that if anyone accesses them, someone is doing reconnaissance. You could, hide it in plain sight. You could, leave it in your CI/CD pipelines environment variable. You could leave it in Slack. Uber had recently, a few years ago, a compromise where someone found credentials in their Slack channel that was used later on. You could leave it in Slack channel. You can leave it in your front-end JavaScript. Or you can also think about leaving no linkability to it. So if someone is enumerating all user IDs, and then randomly user ID 13 is the one that's just a honey token, you get an alert that someone is trying to access that. One quick thing, deploy multiple instances of it. Once you get this alert, you don't want to go looking from where it came from. You should know this particular token was deployed in CI/CD pipeline, or this particular token was in your code base. So you know exactly where your attacker is. This is sort of a catch-all. We talked about specific use cases that impacts all organizations. But for your organization, it could be slightly different. You could have more use cases. So understand the baseline of your API traffic. Distribution by API endpoint adjusted for seasonality. If there's an uptick in a particular API that returns a PII, something odd may be going on. You should look at the distribution by response code. If suddenly a particular API is failing a lot, maybe someone is up to no good. Distribution by source is really interesting. I know of an organization that let people use a one-time coupon code multiple times if the traffic was coming from a mobile application. And soon enough, an attacker just changed their user agent for a mobile user agent, and were able to use their coupon codes multiple times. We talk about source here. Something interesting to think about is user agent a good source? It can be spoofed. Is IP a good source? You could just buy a new VPN service and change your IP. As you go down this list, these are some techniques that you can use to get a stronger guarantee of who is calling your API. You could do server-side hash, you could do client-side hash with the browser properties, or you can do TLS fingerprinting, and it becomes really hard to forge who the real caller is. All right, so far so good. You have your APIs, you've detected a new attack. What's next? I see this oftentimes, organizations are caught in this headlight. Okay, we know something bad is going on, but we have no way of stopping it. That's when you need to have a plan, proactively prepare for what's going on, what you could do in a scenario like this. Generally, it falls into 3 different categories. You could have some mitigations at a session level, like invalidate a session or reduce a session expiry. You should have some mitigations at a user level, like block a user or force them to do a single multi-factor step-up authentication. Or worst come, you may have to take some actions at the API level where you could say, okay, no more user registrations before we fix that. Or maybe change the rate limits, or maybe disable a whole segment of APIs until we know we have contained the situation. Having these methods in your incident response plans are really critical. All right, so quick recap. Collect your inventory. Know what doors and windows you have open. Monitor your API traffic. And have a plan for incident response plan around APIs. In case any of those incidents are happening to you, you know what to do to sort of stop the bleed. That's it from me. Thanks for listening in. You can connect me with these methods.